Good morning, friends. So we have started our chapter 7, statistics, and the basics of our chapter statistics as we have discussed in our last class. I hope that all of you have gone through the class, and I think there is no doubts. So no one has asked me any doubts regarding the basics. Okay. So what all things we had learned in our last class? We had seen about primary data, secondary data, and about the uses of the statistics. Okay, all that things we have seen, and I have given you, I have told you some other practical applications of statistics also. Fine. So we will resume our class. I'm going to share my screen. See, as you can see, we have first we have seen in section 7.1 collection of data. Okay, and there we have seen about primary data and secondary data, all that we have seen. Then I have given you exercise as a homework. I hope all of you have completed that. Then in the next section, 7.3 presentation of data, we have done some examples where in our daily life where we can make use of this knowledge about statistics. Okay, and the two examples we have discussed, and we have seen the range also. I think the definition for a range, see the difference between the highest and the lowest values is called a range. And then we have seen frequency distribution table also. Okay, now we are going to a little bit higher. Fine, in the form of an example only. 100 plants each were planted in 100 schools during one Mahotsava. Okay, after 1 month, the number of plants that survived were recorded as a long number series is given. We condense it into groups like 20 to 29, 30 to 39, etc., 90 to 99. Since our data is from 23, see, when you look at this number, you can see 23 to 98. These groupings are called classes or class intervals, and their size is called class size or class width, which is 10 in this case. See, if we are going just simply frequency distribution table like the previous example, then we have to write each of these numbers. See, we have to take first of all we have to arrange all these numbers in the ascending order, or let it be descending, no problem. Then what we have to do, then we have to check, say for example, if we are taking the number 95, look for the repetition of that number 95 by going through all this. See what a long process will it be. To avoid that, we are going to next level, that is here we are taking class intervals or classes, means like this 20 to 29. So the numbers which lie between 20 and 29, okay, are given or are included in the class 20 to 29. Like that we proceed. Fine. And why we have taken 20 to 29 instead of 0 to 9 and then 11 to or 10 to 19? There is no numbers where there is 0 to 9. Look at the given data. That's why we have told that the data is starting from 23 to 98. So now we are this data, this long and not appealing data is condensed into a tabular form like this. Okay, and again I will show you how we can notate it. See, first of all we have to draw a table. 3 columns should be there. Number of plants survived, then tally marks. In the next column, number of schools. Okay, so 20 to 29, and we have written all this 20 to 29, 30 to 39, 40 to 49, like that. Now we are going our first section, 20 to 29. So our aim is to find the numbers which lie between 20 and 29. Clear? So we are looking here. Go through each of the numbers. Okay, in the first row there is nothing. Now we are going to the second row. As you can see, in the second row also there is no numbers. Then we want 20 to 29. See, first we came across 23. So first, when we have seen the number 23, mark the number 23. Instead of this 23, just draw a line like this, tally marks. Then again we are moving, and as we move on, we can see okay, it means we have missed some numbers. So again we have to go through it. See, here we have missed 28 also. Now again we are moving. So when you have found out number 28, draw one more line. Okay, and again we are moving. "32 is there, 83 is there, 62. So there is one more number. So we can mark all these numbers here. Okay, so all these are marked, and similarly we will go for each case. See, for example, if I am taking 80 to 89, suppose I am taking the case or the class interval 80 to 89, because there are many lengthy. So numbers which lie between 80 and 89, go through it. So 80 and 89. Okay, so when we move on like this, see, we have came across one number, then another number, then again another number. So three of them we have marked, then again 89, then again 81. So look here, 1, 2, 3, 4. Since the 4 markings or 4 drawings, 1, 2, 3, 4. If one more drawing is coming or one more number is coming or repeating, you have to cut this. So it means it is equal to 5. Okay, this box means 5. Then again, if it is coming, mark next to this one more. Okay, it means a total of 6. So just by looking at it, you can say how much: 5, 10, 15, 20, and look, 21, 22, 23. Okay, so you can mark it. So from this we can see that between 80 and 89 there are the number of schools, or the frequency is 23. Okay, and similarly we can change our given data into a very condensed tabular form like this. Okay, I think this is clear to you. Fine. So we have done it, and again, as we have said earlier also, you can cross check whether it is correct or not just by adding all the number of, or just by adding the frequency. If it remains to be 100, then our frequency or our tabular representation of the given data is correct. If it is not, it means there is some mistake. Okay, so we have converted it. Now this is called a grouped frequency distribution table. Look at here. Here it was just simply a frequency distribution table, but whereas here, as you can see, we are changing the given data into classes or class intervals and naming it as groups. So we are calling it as grouped frequency distribution table. Now we can easily observe that 50% or more plants survived in how many schools? Look, we can add it. 8 plus 18 plus 10 plus 23 plus 12, which is equal to 71 schools, which means you can infer from only from this table. You can easily say just by adding the numbers or the class interval from this section onwards. If you add the frequency or the number of schools where the plants have survived, we can see that 50% or more plants survived in 71 schools. Okay, could we say this information just by looking at the given data, which if it was in this form? No. Since we have converted it into tabular form, it is very easy to understand it. Okay, and another thing, the classes in the table above are non-overlapping. Okay, they are non-overlapping, means the number which is lying in this class interval is not included in the next interval. Not that we could have made more classes or of shorter size or fewer classes of larger size also. That is according to our wish. See, here we have taken 20 to 29. Instead of that, I could take 20 to 39 also. That's also possible, no problem. Or I could take 20 to 25, then 26 to 30, like that. That is also possible, no problem. But in either case, you have to be very careful. That's the only thing. And we prefer to choose the table not to be too lengthy or not to be too short. That is the between the which means so long or the medium sized table we are preferring. Now let us go to our next example. Consider the following frequency distribution table, okay, which gives the weights of 38 students of a class. Okay, look here, the weights, if the weights are lying between 31 and 35, look at the number of students whose weights are lying between 31 and 35. 9 students are there. And between 36 and 40 we have 5 students. Similarly, between 41 and 45 we have 14 students, and then between 46 and 50 we have 3 students. Okay, similarly, and go when we are, it is given. Now if 2 new students of weights 35.5 kg and 40.5 kg are admitted in this class, suppose, then in which interval we will include them? That is our question. Look here, we can see there are intervals 36 and 40 is there, 41 to 45 is there, and 31 to 35 is also there. But a student is having, I mean 2 students are having 35.5 kg and 40.5 kg. We will, in which class we will include them? Can we include 35.5 in this class? I mean 31 to 35, or we should include them in second class? We don't know. We will see it in this section. We cannot add them in the ones ending with the 35 or 40, nor the following ones. Okay, that is the problem. We cannot add them to any of the following cases, following classes. Okay, then how we are going to include it? But because we can't avoid them, because they are also present in our class. Then what will we do? In such a case, we will make a slight adjustment. Let us see what is that adjustment. For this, we have to find the difference between the upper limit of a class and the lower limit of the succeeding class. Okay, that is, I'll show you. See, suppose this is the upper limit of a class. Clear? Now what we have to look? The lower limit of the following class, that is 36. Okay, then what we have to do? We then add half of this difference to each of the upper limit and subtract the same from each of the lower limit. Means, what is the difference between these two numbers? It is 1. And what is the half of that 1? It means 1/2 or 0.5. An example is also given to you. If we are taking the classes 31 to 35 and 36 to 40, new interval formed will be, we are subtracting this difference 0.5 from 31.05 and again minus 35 plus 0.5. So what happens? Our class intervals become 30.5 to 35.5. Similarly, the new class formed from this interval will be 35.5 and 40.5. Actually, it is nothing. We are subtracting and adding the same value, same quantity, both both lower limit and upper limit respectively. That is the only thing. We know that in mathematics we can do anything without changing the value. Only that principle is applied here. Okay. Now, can we add the weight of the newly joined students? Yes. But still there is another problem, because 35.5 appears to be in both classes. See, look at the both intervals. Okay, here also we have 35.5. Here also we have 35.5. So where will we add? The student having such a weight. Suppose if it is considered in both classes, it will be counted twice. So it will make our whole process to be wrong. Okay. By our convention, we consider 35.5 in the class 35.5 to 40.5 and not in the previous class. Similarly, 40.5 is considered in the class which 40.5 to 45.5 and not in the lower class. Okay, so this is very, very important. Okay, very, very important, because for exams, when you are asked to or to make a tabular column or include the data, there you will sometimes make mistake in adding the data in which class, so it will make the whole answer to be wrong. Especially when you are moving, we will see some more examples, then you will understand more. Okay, now you can look at this table, newly formed table. We have changed the whole class interval like this: 30.5 to 35.5, then 35.5 to 40.5, and then 40.5 to 45.5, and then 45.5 to 50.5. But look at the frequency. Does any change happens to the frequency? The only change happening in the frequency is in these two frequencies. Look, it has been changed to 6 and 15 respectively. There is no change to other frequencies. It is remaining same. Okay. So the total of 38 becomes 38 plus 2, which will give you 40. Clear? And again, an activity is also given to you, because in the first activity we have divided our class into 4 groups and we have collected some data. Now you are asked to convert that data into suitable class sizes and form frequency distribution table, or in group the frequency distribution tables. Okay, and exercise 7.2 is also given to you. It is actually homework, you can do it, and again if you are facing doubts you can ask me. So I think we can move to our next section, section 7.4, graphical representation of data. So we have seen, first we have seen collection of data. Okay, then we have seen representation of data. Okay, so in that representation of data we have actually seen 3 types of data. First, data is just we are randomly writing them and arranging them in ascending order. That is the type 1 data. Now, in the second example, we have seen the data is being arranged in a table, and we have called them as frequency distribution table. Fine. And then again it has been advanced, and then we have formed or learned one more table where the given data are being converted to frequencies and into classes, and we have formed a grouped frequency distribution table. But again, if we want to make these data, like these data which are in table, even for a, suppose there is a person who is illiterate, he don't know nothing about such kind of data, or he couldn't infer anything from this data. But if we are changing these table data to a diagram, then he may understand a little more. So what happens to a person who have a normal knowledge, and then he is looking at this tabular data converted to a pictorial data, means a graphical representation. It will be very easy for them to understand it. Okay, so we will see what do you mean by graphical representation of data. No problem, just you will understand it very easily. Okay, section 7.4, graphical representation of data. The representation of data by tables has already been discussed. Now let us turn our attention to another representation of data, that is graphical representation. Usually, comparisons among the individual items are best known by means of graphs. The representation then becomes easier to understand than the actual data. See, suppose we are given this data, and we have included this 35.5 and 40.5 also in the graph, in the table, and we have newly formed the table also. But suppose there is another class where the same process happened, and suppose you are asked a question, which class is having a good, means, or students are in which class students having 50.5 to 55.5 are more, in which class, or the frequency. Then even by looking at the figure itself, you can say, but we couldn't compare it. Okay, just a face-to-face comparison will be difficult, even if it is in a table. So in such case, we can make use of our graphical representation. So in graphical representation of data, we will see three types of graphical representations. In this section, we shall study first one, we will see bar graph. Then we will see histogram of uniform width and of varying width. Means histogram, the histogram is again divided into two. One is with the uniform width and the other is with the varying width. And then we are going for frequency polygons. Okay, we will learn each of them clearly, no problem. So first of all, bar graph. What do you mean by bar graph? So what do you mean by a bar? A bar graph is a pictorial representation of data in which we usually use bars of uniform width are drawn with equal spacing with them on one axis. Say suppose it is x-axis, depicting the variable. Now the variables of the values of the variable are shown in the other axis, and the heights of bars depend on the values of variable. Don't worry, these definitions are not necessary for our for exams. Just look at the figure. See, by doing an example, you will be understanding more. So look at the example. In a particular section of class 9, 40 students were asked about the months of their birth, and the following graph was prepared. So obtained. Look here, we know that in an year we have 12 months. So January, February to etc. to December, and we have made a bar graph. Look at January. By looking at this graph, you can easily understand that how we can interpret the graph. Say suppose look for January, and then look at the height of January, where it stops. It stops. In order to find where it stops, just make a left movement. Where it stops at 3. It means 3 students have born in January, in the month January. Similarly, look at June. How many students are born in June? As you can see, only 1 student is born. And in which month the highest number of students have born? You can see easily just by looking at the height of the bar. It is in August. And how many students have born in August? As you can see, 6 students have born in August. Okay, you can easily interpret the data given in a bar graph. See, another question is also given to you. How many students were born in the month of November? Look for the month November. How many students have born? Just look at the the height of the graph. Okay, we are moving from here. As we have seen in coordinate geometry also, that is the underlying principle. And we are moving to the left. Okay, so we arrive at 4. It means 4 students have born in the month November. Now, in which month were the maximum number of students born? Just look at the height of the bar. Just by looking at it, you can easily say, of course, it is August. And how many students have born in August? I'm just writing it as August. And how many students have born? 6 students have born. Okay. So I think this is very clear to you, and it will be better for you if you are learning till here, and then we will be moving to next examples. That will be better. Okay, I'm not giving you overload. Just learn each and only small portions I'm teaching you each day. So just go through all the classes and learn them very well. Okay, and ask me if you have any doubts also. So thank you.